Hey everyone, welcome to yet another video of Harness Community. My name is Jyoti and I'm one of the community engineering intern at Harness. In this video, we'll see how to get started with test intelligence in Harness CI. So without any further ado, let's begin. So what we'll be covering in this video is an overview of what test intelligence exactly is, the different language support that Harness has for test intelligence. We will see a hands-on implementation of TI on a public repository and also understand the benefits of test intelligence and what's next for test intelligence. So let's talk about test intelligence and what it does and how it is useful, and also understand what are the different supported languages that we have at Harness. And at the end of this video, we'll also use it on a public repository, let's say an Apache project. So yeah, to give an overview, test intelligence is a way where we kind of create a relationship between the tests and the source files. So let's take an example when a pull request is raised, right? Instead of running like all the tests in a test suite, we are going to run only the selected tests which are impacted by the change. So let's say if the test suite has around 1,000 tests, but you particularly make a change to only single file, you don't really have to run all those 1,000 tests. You will only run the tests which are really impacted by that change. Now, how we calculate this change is by something called as a call graph. Now, TI can generate call graph by injecting something called as an agent. So with the time of the test, when the tests are run as a part of test running, let's say you're trying to run a Maven test command, right? So to run a Maven test command, you'll inject something called as a Java agent in the command. So what the Java agent does is it is going to trap into all the class loading processes, and it is going to create this call graph at the entry and exit of every method, right? So overall, TI dramatically improves test times by running only the test required to confirm the quality of the code changes and the triggered that triggers the CI pipeline. And if I talk about the components of TI, there are majorly three components: the service, the runner agent, and the run test step, right? So the service is agnostic to the CI solution. It is used in the selection phase. It uses a list of the added or modified files with the call graph to identify which test to run. If we talk about the runner agent, it is responsible for the communication between the TI service. It runs the test with the instrumentation on, and after all the test completion, the agent passes the test results and uploads the results along the newly generated call graph. The test step, that is a run test step, is similar to the run step, but it accepts some additional information such as the programming language of the source code, build tools, and other parameters which are specific for TI. And it identifies the programming languages and uses the test step to run the selected test in the test step container. So let's try to build test intelligence for our pipeline from very scratch. Now, again, keeping in mind the constraint where currently we have the support only for Java and .NET, and the .NET support is behind the feature flag. We are also coming up with support for Scala and Kotlin in the upcoming days. Cool. So the first step obviously is to create the CI stage, right? We start with the CI stage, a very basic CI stage, and the next step is to add the code base. Now, this is something that you are already probably familiar with, right? Adding the code base and setting up the build from infrastructure as well, right? In this case, it will be hosted by Harness. That's hosted builds that we already have. Next step is to create the run test stage, and this is where the things get very specific for TI. Now, instead of a usual runs tab, we use something called the run test tab because these are some extra fields that are relevant to the test intelligence. Now, let's say you'll give to configure the run test tab, right? You'll give the name to the test, you'll specify all the fields and everything. But after that, things get very specific to TI. So you select the build tool right here, right? So this comes definitely after the language. And when the language is selected, you can select the corresponding build tool as well. So in this case, if the language is Java, then you have the options for build tool as Bazel, Maven, or Gradle, right? After then, you specify your packages. Now this is an optional field, so this will get auto populated if you are not specifying these packages. These are auto detected by our agent, right? There is another field called test annotations, right? So this is what like if you have any custom annotations in your test package, so if you add those test annotations, one requirement in Java or C Sharp for that fact matter is that the test should be annotated with something called as an edge test. So that is how TI understands basically that yes, these methods are my test method. Otherwise, we cannot say that yeah, this is my source method and this is my test method. So that's why they should be annotated with the test. Now, again, if they like in case as a user has a custom annotation, right, they can specify in the test annotation itself. So some of the popular default annotations that we support are JNAT, there is Jupyter API, there's Eng frameworks, and many others, right? Cool. So now since we are setting up TI for the first time, right? So let's assume that we have not executed this pipeline with TI beforehand, right? So when you select TI for the first time, we have no information about the call graph with us right now, right? Because this is the very first time we are doing this, so we cannot be intelligent yet. So how can we be intelligent is only after we have the call graph information with us, right? So once we have the call graph information, we'll be using that information in the subsequent runs for our pipeline, right? So the first step is to perform in this case is something that is called as bootstrap, right? So bootstrap is the one that generates the initial call graph, right? So how do you set a bootstrap? So I'm assuming that you're already familiar with how to configure webhooks, right? So one thing to note here is that TI does not kick in automatically, right? So it does not really work manually. So when you run a pipeline manually, a pull request has to be raised by a webhook. Only then TI is kicked in. So this is a very important thing to note, right? So you configure the webhook of the for that particular project, and then you can make any small change, raise a pull request, and then you can merge that pull request. Another important point to note here is that when you open a pull request, the test gets run, right, and the call graph gets generated and it is stored. Now the call graph that gets generated during the pull request, when you open a pull request, is not persistent, right? Because the pull request has not been merged yet. Only when you merge the pull request, the call graph gets persisted in harness. So if you take an example, let's say you have a project and you're raising a pull request from, let's say, patch 1 branch into develop branch, right? So the develop branch is your target branch and patch 1 branch is your source branch. So when you raise this pull request, we take this information about what is the source branch, which is the target branch, obviously the repository, project, pipeline name, organization, account name, and all this information is gathered together when you raise a pull request, right? So agent gets injected, next step, right? When the tests are run, and as a part of it, we generate a call graph, and then it is stored somewhere, let's say in a temporary storage for now, right? And then when you merge the pull request, the PR gets merged into the target branch, which was in our case develop, right? So then we update the call graph saying that, hey, this call graph belongs to develop branch, right? And which was our target branch. So that's how we differentiate call graphs for each different branches, because code could be different in different branches, so the call graph will also be different in different branches. So it is completely associated with the branch. What does TI sync with the test, right? So there are three ways how TI can sync with the test. First one is a changed code. So TI queries Git to learn, uses Git to learn to exactly which code has changed in a specific build. When a specific test is change is identified, TI chooses it even if the code, if code it hasn't changed. There's a new test. As soon as harness identifies a new test, it automatically selects it, right? And after each test cycle, you'll have the full visibility into which test was selected by TI and why. And you can also see the visualization graph on the pipeline tests page. Now, if you have to find more information on this, you can definitely jump into the documentation of test intelligence, the test intelligence overview docs that is available in the ng docs of harness. Then we also have the documentation of setting up a test intelligence, just thing that we cover right now. You can run through that as well and try implementing it. And we also have a few blogs around test intelligence. You can run through them as well. And in case you are facing any difficulty in executing the pipeline with test intelligence, feel free to join our community Slack channel. You can find the link in the description below somewhere in the YouTube video itself. And then there's an entire community engineering team to help you out in the process, right? So yeah, with this, we'll move ahead and try to have the hands-on implementation on an Apache project for test intelligence. Test intelligence on a public repository in GitHub. In this case, we'll be using the repository of Apache, that is a RocketMQ project, and I have already created the pipeline. So let me just jump to the pipeline and show you how it looks like. Pipeline that we are using, in this case, we are using the Apache project of RocketMQ. We have a stage here under which we have two different steps. Now we will be referring to this run test on VM because we are using the runs test step here, right? In this case, we are using the language as Java, and if you see, we have an option to enable error tracking, which we have marked as no. The build tool can be changed depending upon your requirement. That we have option for Bazel, Maven, and Gradle for Java. In this case, we'll be using Maven. Also, it is not just for the run test step, it can be even true for the run step. Let's say you're running test for some non-supported language, let's say Python. You cannot use run test step because we only support Java and .NET here, right? If you want to run it in Python, what would you use is a run step and run your own standard way of using PyTest command or whatever. But if you want to see the test report, you'll have to still specify this. Even if there you need to specify the path, so that's about the run test step. So if you see the language for the Java build tool is Maven again. One thing we need to do is your pom.xml has outline. You get this question mark here, right? Does your format XML contain outline, or are we attaching another agent? Because like I said, Java agent gets attached when we run a TI step. But if a customer or a user is also attaching any other agents like a JK agent or a code coverage or anything else, they'll have to update their form XML, right? With this, I'll show you an example on how it is updated in this open source project. So if you see here, we already have a template given us which we need to copy and change the configuration based on our requirement. So this is something that we inject in the command line that we create at the end, and then we also add this. So this is saying harness outline, and then this is updating the outline by themselves. Test intelligence does not get invoked directly. For it to get invoked, we need to have a webhook or an event activity, right? So let me just show you the GitHub repository that I'm talking about. So let's move to our project, which is RocketMQ in this case, and Octet. And if you see here, there are no pull requests, but there are already 5 closed pull requests, right? So for each of this, if you observe, there are automated tests that are running. And let me just move to the pipeline once again here and see the execution history. Now, if you see here, these are invoked manually. So TI does not get invoked directly when you execute the pipeline manually. It only executes or invokes when you are doing it with respect to the webhook. So if you see here, this is a pull request getting open where we are trying to push we're trying to implement test engine from code with patch 4 to develop, right? And then when it gets merged, it again we have another pull request here which is merged from patch 3 to develop, and we are tracing this. So this is where TI actually gets involved. And since this is the first time we are executing this, this is where our first call graph will get created. So let's try to understand what we're talking about here. Let's me move. This is a execution, and these are the logs that we have. Let's move to the test section, and if you see here, we have got total 1105 tests, and all the selected tests, all the tests are selected because this was the first time where we exactly accurately invoked test intelligence. Now we have the test selection breakdown section here. We have the test execution results section. We can also check only for the failed tests by filtering it here. You can also observe the call graph in the bottom corner. So this is how we basically implement test intelligence in Harness CI. Moving further, we can understand what test intelligence benefits are. Let's take an example for it. So if you see the average test execution time without TI and with TI, and just compare some of the major open source projects that are available right now, which is, let's say, for example, Harness Core, the Harness Core project in Harness organization in GitHub. The average test execution time without TI is 43 minutes. With TI, it becomes 32 minutes. For RocketMQ, which we just did right now, is for 4.6 minutes without TI and 3.1 minutes with TI. So of course, there is a huge drastic change in terms of the execution time, which definitely helps us to reduce our time in test execution, and also helps the entire pipeline to become more efficient for us, right? So yep, that is pretty much it about test intelligence in this video. Of course, there is much more to test intelligence. We have topics covering parallelism with test intelligence as well in the upcoming videos. So keep tuned and subscribe the channel, press the bell icon, and keep you updated. Just join the Slack channel. You must have find the description below, the link somewhere below the description. And yep, thank you so much for joining this video. Thank you so much.